For number 2, we've got the masses in grams of 690 medical supplies, and they're given this table. And they want us to find the value of P, and they want us to graph a histogram, and they want to calculate an estimate between 8 and 18. So first, let's find P. All right, so they tell us there's 690 samples. Well, that means that these numbers, 224, 396, and then P must equal 690 because it's a grouped frequency table. So this is how many times each thing happened. And the 690 is the total number of times it happened. So that means we got P is equal to 70. Now, to make a histogram, we need to know the boundaries. And first thing we want to take a look at is, are there gaps? And there's no gaps in this case. So what we're looking at are actually the actual boundaries. So we can now establish the class width. This is 12 minus 4 or 8, 24 minus 12 or 12, and then 28 minus 24 is 4. And then the next we need to do for our histogram is come up with the frequency density. That's going to be the frequency divided by the class width. And that's going to be for this first one, 28. And then the second one, it's going to be 39, or 396 divided by 12 is 33. And then the last one, we're going to do 70 divided by 4, and that's going to be 17.5. So those are our frequency densities. So now what we want to do is take a look and set up the scale for our graph. And we look at the numbers, and we're going from 4 to 28. And so I'm thinking I'm going to go by 5s. And it's a good idea to label your axes early. They're late, because usually you forget when it's late. Anyway, I'm going up by 5s. And then I look at my frequency densities, and they also look like they're going to get close to from 0 to 33, 35. So I'm going to also go up by 5s. And see, now I've made my scale, and I've labeled both of them. And now I'm going to plot the columns. And the boundaries are going to be the width of the columns, the actual boundaries. And in this case, I'm looking at them. And then the frequency densities, that's how high each column is going to go. So we start off with the first column, and we get to 4, and it's going to go to 12. And so we're just estimating here. And then all I got to do is go up to 28 and then make a column. And it's a great idea if you use some kind of straight edge so it doesn't look sloppy. Now I go to the next one. The next one goes up to 33, and it goes from 12 to 24. And again, you'll notice I'm just estimating. And then the last one is going to go from 24 to 28. It's going to be skinnier, and it's only going to go up to 17.5. All right, there's my graph. Now for the last part, they want us to make an estimate between 8 and 18. Well, that gives us a couple rectangles here, and I'm going to make this one here. This one goes from 8 to 12, and then this one goes from 12 to 18. Now, each one of these rectangles, if I take the area of those, I can figure out the frequency, because frequency density is equal to frequency divided by class width. That means frequency must be equal to frequency density times class width. When if you look at it and the rectangles, that's the base times the height, or the area of each one of those rectangles. So what I'm going to do now is figure out here. So like I said, this goes from 8 to 12. Let's go ahead and mark this in, 8 and 12. And so there's a difference of 4. So this has got a base of 4, and the height we already know went up to 28. So 4 times 28 is 112. And then here we're going from 12 to 18. That's got a height of 33, so 6 times 33 is 198. Altogether we've got 310. So approximately 310 samples were between 8 and 18 grams. Okay, I hope that makes sense. Thanks for watching.